Okay, hi, hello everybody. Welcome to this video in a series of videos on um, safety inventories. In this, we'll talk about the idea of component commonality and how does component commonality impact the value of aggregation in safety inventories, right? So what is component commonality in the first place? So sometimes you might be manufacturing different product lines, but many of the product lines might have the same component. So think of Apple manufacturing all these different MacBook Pros, right? But there are many components that are common to all the MacBook Pros. They have the same keyboards, they might have the same trackpads, they might have the similar screens depending upon the models that you have. So given all of this, they have the same camera, for example. So given all of this, you don't have to manufacture separate components for each of these things. You can manufacture some common components. So when you look at demand just for the cameras, the FaceTime cameras that go into these MacBook Pros, you don't look at demand for each product line individually, but you look at demand for all MacBook Pros together. So there is aggregation in demand, right? So how does component commonality affect that? So that's what we'll talk about today. So if you have manufacturing without common components, uncertainty of demand for each component is the same as that for the finished products, and this usually results in high levels of safety inventory. But with common components, demand for a component, so because you can aggregate the demand for component, usually the demand for components will be more predictable, standard deviations will be lower, and so the safety inventory will also be lower, right? So let's look at an example from the textbook here. So let me quickly show you the example here. Component commonality, right? So assume that Dell is to manufacture 27 types of servers with three different components. So you have processor, you have memory, and hard drive. Those are the three big components in any server. Under the disaggregate option, where you are looking at each of the different 27 types of servers separately, you have to manufacture three different components for each of the 27 servers separately. So you have 81 distinct components. So because there is no commonality in them, you have 81 separate components. That's a lot of components to keep track of, right? Under the common component option, Dell designs servers such that you have three distinct processors, three distinct memory units, and three distinct hard drives that are used to create the 27 server types. So you can say that you have three types of processors, you have three types of memory units, and three types of hard drives. And the mixture of these is what is giving you the 27 server types, right? 3 times 3 times 3, that's 27. Now, each of these components, in essence, will end up in 9 of these different types of servers. So you have 27 distinct servers, but 9 of those servers will have the same type of hard drive. 9 of those servers will have the same type of memory units, and 9 of those servers will have the same type of processors. So there is some commonality in components. Now, we will assume that the monthly demand for each of these 27 servers is independent, again, no correlation, and it is normally distributed with a mean of 5,000 and a standard deviation of 3,000. Replenishment lead time for each of this is about a month, 1 month. And Dell is targeting a cycle service level of 95% for component inventory. So evaluate the safety inventory requirements with and without the use of component commonality, and also evaluate the change in safety inventory required if the number of finished products of the component varies from 1 to 9. So we'll talk about that too, right? So let's first look at the disaggregate option, then we'll look at the aggregate option and see how they are different. So the standard deviation of monthly demand is 3,000, right? So that's the standard deviation of monthly demand. Now, if you have 27 servers and three separate components, so you have 81 separate components, and you are holding safety inventory for each of those 81 components separately, then the total safety inventory will be 81 times the safety inventory for each individual component, which will be the inverse normal of 95% because that's the cycle service level, times the square root of 1 because 1 month is the lead time, and 3,000 is the standard deviation of monthly demand. So in essence, you'll be holding 399,699 units, in safety inventory of different items, but we are assuming that the costs are similar. So we are looking at each of these items. So we have so many components that we are holding in inventory. But if you have component commonality, in a sense, nine of these end up in, so you have nine separate things that you have. So nine components end up in nine finished products. Therefore, the demand at the component level is the sum of the demand across these nine products. So let's look at one group of these products, and then we'll multiply the value by 9 to get how much safety inventory we hold. So for one group of these products, you have inverse normal of 95% times the square root of 1 for the lead time times the square root of 9 because you have 9 separate products, so the square root of 9 times 3000. That gives you a safety inventory per common component of 14,803. So you'll have 14,803 units of memory units. You'll have 14,803 units of the common components that you hold. So with component commonality, there are 9 distinct components that you have. And so the safety inventory across all the 9 components will thus be 9 times 14,803, which will end up being 133,233, which is basically a third of this. And that's because you have 81 here, and you'll end up with, 9 times square root of 9 rather than 9 times 9. So that's what you end up with. Thus, having component commonality reduces the safety inventory from 3,999 to 6,699 units to 133,233 units, right? And you can do the same example based upon the number of finished products components that you have. And so you'll notice that there is a lot of reduction in inventory that can happen, right? And that's the idea of component commonality. It's a very simple concept of looking at components that are common to different product lines and aggregating their inventory rather than holding separate inventory for each of the distinct components, right? And that's the idea here. Now, okay, so again, this is a shortish video. I'm gonna stop this video here. Postponement is a much longer topic, so I'm gonna do that in a separate video. Right? I'll see you all in the next video.